Well, hello, VOCE Global. I am very excited to bring this conversation to you. I'm here with Will Williams from Speechmatics. Many of you are familiar with Speechmatics because they've made a big impact on our industry. Will, thanks for joining me. Can you jump in, introduce yourself a bit, and just let us know a bit about you and your company?
Sure, thanks very much for having me. So yeah, I'm Will. It's one of the first few employees at Speechmatics, who are a company based in Cambridge in the UK, who do speech-to-text software predominantly. And we feel like we're real sort of leaders in this industry, really pushing hard on the machine learning side of things. Yeah, I was one of the first few employees there, kind of have a background in computer science, and then I wanted to kind of jump into machine learning. So I've been doing that for the last 9 years. Kind of done a bit of everything there, actually, right from machine learning to some of the kind of more traditional distributed systems, architecting things. These days I'm heading up our R&D department there.
So why don't we start by talking about the state of play in speech to text. So maybe you could just give us some insight on that. I'd like to hear about it.
Yeah, sure. So during my time working on speech to text, I've seen a real dramatic shift in the quality of the output. Error rates have kind of fallen through the floor. And so I think today we find ourselves in a position where if you have quite controlled conditions, if you probably ran our software over this talk, you would most likely get perfect output. If you're running with maybe simple voice commands, you have a clear accent, also you may well get completely perfect output, or very, very high accuracy. Outside of that, today's best systems are still pretty good, I would say, but still not perfect. So if you're talking with maybe a challenging or an unusual accent, or you're running the software in challenging acoustic conditions, there are still going to be errors in there. So we're not quite at in the sort of this kind of final throes of ASR where we've reached a point where it's a completely dependable solution where you can bank on every single word being correct. We're not quite there, but I've seen dramatic drops in error rates during my time, and I think we're at quite an exciting point where actually getting to that kind of level of perfection does feel like it's within striking distance, or at least we're getting very close.
So do you think the drops in error rates are because technology is getting better only, or is it because there's more users and more data? What's the combination of reasons why error rates are going down right now?
Yeah, I think there've been a number of drivers at the same time. So data has obviously had its own thread in that story, and all the modern deep learning systems that have kind of transformed the industry have required huge amounts of data, label training data, in particular, and that's been driving the error rates. Certainly from say 2012 to, I don't know, 2018, like the supervised learning with large amounts of label data, really that has been driving the error rates down. And then I think there's been like a few innovations on maybe the kind of the architecture side, so that, the internals of these systems, as in many parts of kind of the conversational AI pipeline, the transformer has just been able to soak up this data and scale incredibly well with it. And maybe we'll get on to talking a bit more about this, but the unsupervised side of things has really transformed things, in particularly the last 2 years, I'd say 2 or 3 years. And that's kind of been another wave of things dropping. So maybe you have the first phase is kind of mainly data and exploiting kind of deep learning architectures, and then you have this kind of unsupervised wave that's really pushed it down further, something like that.
And what do you think is the combination of humans and machines in order to take us to the next level? I mean, because it's people working with the technology, making it better, and there's this combination of the two. So is it a 50-50 need to where we're going, or is there more emphasis on great employees and working really hard, or great technology getting better?
Yeah, so I think there's a mixture of things there. So like, if you extrapolate the current trends on the technology side, we'll just get steady gains in terms of accuracy and latency and performance. But then there's kind of what I call more the API layer, where we're doing things like very simple things like spelling maps and inverting spoken form into written form, so getting numbers written out correctly. Where there's lots, this is just like finessing the API, and I see that as a very kind of human-driven thing. How should this thing be output and printed to screen? And there's, yeah, that takes a bit of care and a bit of thought, and not quite everything can be scaled through with data there. So I see there's a human aspect there. But then maybe if you're talking about the final 1% in these systems, I think you have a much more dynamic human in the loop scenario where where the system has to understand maybe the user's state of mind. So you need like theory of mind to be able to push that final 1%. So that's way beyond having developers, but then having a user that can interact with a system and it can learn to push that final 1% of accuracy for you. Yeah, so that's kind of how I see it in those kind of three buckets.
Well, we've covered some ground on where things are at. Maybe we could talk a bit about where it's going next. What is the next and the new era? Give us some insight in terms of where we're going.
Yeah, so I hinted at this kind of big drop in error rates coming from unsupervised learning. And I think we're in this kind of era now of what's been called representation learning. And sort of shamelessly stealing this from Chris Madison, he did a presentation quite recently where he had three eras. He had feature engineering, and then deep learning, which is like 2012, 2011 until a couple of years ago. And now we're in this representation learning era. And if you're on Twitter, there's lots of incredible things happening right now in terms of generative modeling and incredible feats of large language models that can help us generate images that we never thought we'd be able to generate before. And really, this is kind of this is all happening within this representation learning era, where we have lots of ingredients from the sort of deep learning area. We have like this whole scaling with data thing that's still happening. We have like really expressive kind of like features that are able to be learned, but it's being powered predominantly by unlabeled data. So in the case of speech to text, that would just be millions of hours of unlabeled audio. And out of these systems, we're training them in such a way that we have these kind of multi-use features. So we train these networks, they get good at some kind of task that you set up, some kind of prediction task, and then you end up with these multi-use features, and they're not just like one use. Maybe say you have a classification task, classify this like window of audio, classify which phoneme was spoken. We've got these multi-use features that can be used for many, many different tasks. And we're seeing that with these large language models. You can put in a prompt, and you can completely, you have a product per prompt almost. So it's like, it's not just multi-use features, but it's almost like multi-product view that you can take through these whole networks. So it's pretty exciting, and we're seeing kind of lots of new kind of products being able to be built on these kind of technologies. And it's kind of not really letting up. The people who can build these large models are seeing great success right now. Their error rates are dropping. They're seeing new capabilities able to be displayed through them. So I think it's a very exciting kind of era to be in, and it does feel different to before. The task isn't so much to go out and have huge numbers of teams collecting labeled data for you. That's not, I mean, that's still part of it, but that's not really where the frontier is these days.
The speech to text element impacts lots of different sectors. And so I'd like to cover these. So, I mean, obviously data requirements, machine learning engineers, and of course, customers. Maybe we could start with the impact on customers. So when you think about the speech to text impact on the end user, where are we at? Where are we going? How should people be thinking about this?
Yeah, so given that sort of the state of the art in speech to text is being powered by lots of these kind of self-supervised models, when you want to talk about impact on customers, I think you're thinking around more robust models. So if your input is perturbed in a particular way, you should still be getting similar outputs. If you're augmenting it in weird ways, you should still be getting similar outputs. if you've got a peculiar accent, you should still be getting reasonable error rates. So I think there's like a robustness piece to this, and I think models will be getting more and more robust, and customers should be expecting that. Another part of this kind of trend, I think, is customers should expect a more unified experience. And by that, I mean more and more problems are going to be joined together in kind of one neural network in the future. And I think, traditionally you might have lots of disaggregated APIs, and those APIs might tell different stories. So, take the example of, in our case, speech to text and diarization. So diarization, who spoke when. ASR and diarization might tell slightly different stories if you had completely separate APIs for them. You might have a speaker you might have speaker A and speaker B changing in the middle of when a word was claimed to have been spoken. So things might not make sense. And I think the future is that we have sort of a slightly harmonized system where a single model will tell a single consistent story. So I think like a number of these APIs will be gradually more and more aggregated together, which hopefully means there's less kind of engineering work and hackery that needs to be done to make these things make sense together. On the ML engineering front, I think there's going to be a kind of an increased focus on handling these larger models, and because lots of them are kind of we're pre-training, we have these different phases of pre-training and then fine-tuning. There'll be lots of trade-offs that will require, I think, the attention of ML engineers. So when do I freeze? When do I unfreeze? Which models do I join together, and so on. So I think there's kind of a new world emerging there, and then where does specialist knowledge fit in, and where should it fit in? How much do I leave to this kind of these general rich representations that might be trained from labeled audio, and how much am I going to focus on training a sort of a specialist? I think these are interesting trade-offs that will start to be discussed more and more.
Could you dive in a bit deeper from a technical perspective? I think, let's say the VOCE Global audience is at least at a 201 level, right? But if you're speaking to the experts, if you're speaking to your peers, those at the 401, right, they really understand this. What are some things on your mind that you think they should be considering and thinking about based on your experience being at Speechmatics for the last decade?
Yeah, I mean that's a tricky question. I mean, I think one of them is how do we exploit some of the magic that's happening in large language models right now. So there's this phenomenon of in-context learning happening very, very implicitly, where you have zero-shot learning occurring, and it's not just that we can memorize, we can do a good job with the probabilities. It's we can exploit context in a very, very implicit and dynamic way. How can that be harnessed in the models of the future? I think that is a really, really interesting question. How can we do it outside of language models as well? So maybe for those people who aren't familiar with in-context learning, the idea there is that you get better at a task at test time whilst retaining a completely frozen model. So the weights do not change in your network, but after being exposed to a certain input for a while, the system can get better and better at a particular task. And so, this kind of in-context learning it feels very magical in some cases. How can that be best be exploited? And that wave is here. How can we make the most of it? I think that's kind of the question I would pose.
So in terms of this era, nobody knows, you're not Nostradamus, but in your mind, how long do you think this era will last? How long of a season are we in that will be similar to what we're experiencing right now?
Yeah, so it's obviously incredibly difficult to make predictions, but I'm always happy to just take a stab. I don't know. The previous eras they've been around 10 years. Maybe that's kind of the length of time that we're kind of talking, where a paradigm we exploit it for a while, and then there's the next one that continues. In some sense, there's nothing that I can see that really would be stopping this trend. we can exploit data, we can get incredibly expressive networks. We can get these multi-use features that seem very general and useful for many, many products. So I don't see particularly what is, so in the same sense of the other is they, to some extent, will also continue through time. I think this will continue. Maybe it comes to an end when the compute limitations force us to. So maybe there's a point where we can't just naively scale these models and see good results, and we have to switch to some other approach, and maybe that will precipitate the next era. I don't know. It is quite hard to say. So maybe, maybe the next era is like has a different focus on efficiency because we've hit computational limits, but maybe we never do. So yeah, hard to say, but there's just some thoughts on that.
What do you think are some leaps that are still likely to happen within this era? What are some developments that will still happen in this season that we're in right now?
Yeah, I mean, so I can maybe speak first and foremost from my experience of speech to text. I think we'll get past that threshold of reliable speech recognition where we hit like the 99 plus kind of accuracy rates, and I think like within that, new kind of applications will be possible where we really start to rely on the output of the ASR. I think kind of generative image and video modeling, that's really going to go crazy. I think there'll be increasingly impressive feats of reasoning that come out of these large language models, which will have its own impact on the kind of conversational AI platform. So, you're going to have more or less perfect kind of ASR, and you're going to have some, next level reasoning happening on top of it. That's almost certainly going to happen. More than that, I think there's a definite trend towards like multimodal integration. So maybe in the kind of, I don't know, last 10 years, there hasn't been a real need to develop multimodal machine learning systems. It's almost been a nice to have. I think it's going to be more table stakes, and maybe you'll see crazy things happen, like learning image classifiers based purely on audio and video data, and not having like a traditional labeled data set. Maybe there's a few paradigm changes to come of that kind of order. Certainly the multimodal, the move to multimodal models is definitely going to happen. Unsure about its impact, but I think that's going to be a definite trend to watch.
So, sometimes we're in our own insular bubble in the voice tech world, the speech to text world. And, oftentimes people outside, their only, experiences, maybe what they do when they talk to their phone or talk to a speaker or something of that nature. Maybe they talk and it writes out a text message. But if you could talk to people that are not in this industry, right? The plumber, the restaurant owner, right? The taxi cab driver, that type of person, they go, why does this stuff matter? Why is this good for me? Why is this good for humanity? Why will my kids benefit? What's kind of a general thesis by which all this technical development is good for humanity?
Yeah, maybe there are two kind of stages immediately pop to mind in that. So there's kind of efficiency saving stuff. So, dictation becomes incredibly easy. Simple voice commands, like maybe that makes some workflows easier. I think that's like the phase one kind of stuff. Then there's like, I think a really exciting future beyond that, where we have these really, really in-depth conversations with our computers, and we get them to do our bidding for us to some extent, execute difficult tasks or execute simple tasks. I think that's the kind of exciting economic future, and maybe even just like personal future with being able to do more and more with our computers. I think that's the future beyond it, that maybe the taxi driver can start relating to that, because in some sense, like, yes, we can do a lot already with our phone, but I think it's this future that's beyond that, that's quite exciting.
I think one of the things that is special about any company is the company's founder. Tony Robinson has a great reputation. Obviously, this company, Speechmatics, wasn't started last year, or even 10 years ago. Can you give a little insight in terms of the founder, Tony, and maybe just let us know a bit about him and the journey that he's had to bring Speechmatics with you and the rest of the team to where it's at today.
Yeah, sure. So Tony was really working on recurrent neural networks back in the late 80s, and yeah, trying to get them to work, and he did to a certain extent. But yeah, the compute wasn't there, and that really only came around the time when I joined Speechmatics, kind of 2013 sort of time. So Tony's obviously, you know, an expert in speech recognition, and has been, yeah, pushing lots of different approaches. And I guess as Speechmatics itself has grown, we've kind of developed a few of our own kind of areas in which we've done well, and one of those was on the recurrent neural network side of things. So pushing the language modeling, scaling it to quite large sizes for the time. That was some of the work that Tony was involved in when I joined the company. So yeah, I mean, his expertise has really really kept us on course, and kept us sober about different trends that have come and gone in speech. And yeah, has really left us with yeah, a strong speech engine that we're using and selling today.
You may not have an answer to this question, but I'll ask it in case you want to speak to it. You know, your company powers a bunch of innovative companies. You know, Deloitte comes to mind, Veritone comes to mind. Can you speak to the importance of collaboration and different companies working together so that both kind of multiply each other's impact, and finding ways to you know, find a win-win solution together in the fact that they lean on you for some of the tech stack that you've built?
Yeah, I mean, being able to find these kind of win-win scenarios is so great. I love working with companies who are open to collaboration and give us lots of feedback, and you know, can help us bootstrap in different ways. Yeah, I mean, we've been putting effort into developing a partner program internally. We want to keep improving that because it's so valuable when we find customers who really benefit from us thinking through their problems, and we benefit from the things that they can offer us as well. Yeah, we do see those kind of feedback loops in speech to text. So that, yeah, sure, it might be on the data side, but even just providing qualitative feedback is incredibly useful. Yeah, and so yeah, we've had we've had a number of productive relationships like that. I think it's a good area where that's possible.
What is the best approach when a prospect is reaching out to Speechmatics and saying, "Hey, saw what you did for Veritone, or seeing what you're doing with Deloitte. Can you help us?" So what's a good starting point for anybody that's watching here with VOCE Global and they think, yeah, I didn't really consider what Speechmatics could do for us. What's a way to kind of get started? They just go to the Speechmatics website and fill out a form, or what would be the process to kind of get the ball rolling?
Yeah, so this is very timely, which we've been building a portal on speechmatics.com where you can just go and upload audio, and there's a number of free hours that you get each month. That would be the best way to get going. I think right now you need an API. We're looking to improve this experience and just make it frictionless, so you can just turn up and dump your audio and see what we like, and see what we're like. And I think that's, to be honest, the way to evaluate speech providers. Everyone can make a bit of a noise around how good their systems are, but you do just have to run it yourself to find out if it works for your use case, and who's doing really well for your use case. So yeah, speechmatics.com, and just sign up, use some of the free hours that we give you.
So I want to ask you two last questions before we wrap up, and both are on. Well, here they are. One is, why would somebody want to work at Speechmatics? You know, it's hard to find great talent today. And there's lots of people that need machine learning engineers and all these different types of roles that Speechmatics would hire for. What would be a reason that people should consider, lean into, take a look at your job descriptions that you post now or in the future? Why is Speechmatics a great company to work for?
Yeah, so I think we're really good on the innovation side of things. So we've got a lot of exciting research projects going on. We're obviously at the cutting edge of a particular industry. And I think that industry, as I said earlier, it has this exciting future just ahead of us, and it's within kind of touching distance. So if you're the type of person that wants to work on that future where we will have those deep interactions with computers, here would be a great place to kind of make that happen. I think on the software engineering side of things, I'm speaking mainly to the kind of the engineering side, because that's where I'm from. There's just lots of good challenges, just from a pure computer science perspective, building efficient systems, making it work really well. There's ability to touch lots and lots of different types of problems. So I think you can be exposed to lots of interesting challenges here at Speechmatics.
So here's my last question, and maybe a bit more personal. Why is your career path a good one? And so I'm thinking of the high school students watching VOCE Global right now, right? I'm thinking of the freshman and sophomore in college watching our conversation right now. And everybody's telling them, you should become a Solidity developer and go do smart contracts for NFTs. And you should do this thing in finance. And why should they pause for a moment and consider computer science, machine learning? This has been your career. You've really been successful in it. So can you give some encouragement to some young people or people considering a change in their career that maybe are a bit older? Why is this a wonderful career path? And maybe we could end there with our conversation.
Sure. Yeah. Maybe I'll just share the way that I think about it and see if that resonates with people. So, to some extent, you always want to live in the future, and you kind of want to make decisions now that kind of flow backwards from that. And I think there's increasing evidence now that a lot of the innovations of the future will be based on machine learning technologies. And so it's probably it's not an unreasonable idea to want to be the person who's involved in developing those things. So there's a kind of a like, maybe that's a pure kind of argument, but then there's also if you enjoy innovation, this is where a lot of the innovation in computer science right now is happening. Computer science departments have had huge upticks in the number of people that have switched over and demanding to do machine learning courses, and that's there's probably a lot of things driving that, but I think that future reality is probably one of the things that's impacting how people are starting to think about this. So, Andre Karpathy talks about, software 3.0, I think it is. This is like, so, the future of software itself will be around handling data, handling models, not necessarily building things up from scratch in the traditional way. And this is kind of the future, at least, that people like him put in front of us. And even if that's 50% true, it's still probably a high enough probability that it makes sense to consider computer science, machine learning, and then maybe even speech as an exciting area to work in and pursue.
Well, Will, thank you for jumping in, for sharing with VOCE Global. I want to say, I think not only have you been a great representative of your company, Speechmatics, but you've been a great representative of what it is to be a computer scientist. And I think people will find encouragement by which they hear, and hopefully education. People will walk away from our conversation feeling like they learned something great. So thank you for joining us. Thank you for being a part of this amazing event. We honor you and all the wonderful things that Speechmatics are doing. And of course, we're cheering all of you on, and many of us are already engaged with your company. So thanks for being with us, and until next time.
Thank you very much. Goodbye.